switch out of this class?
They shook up a little bit. Okay. All right, now let's get our note sheets out. You guys see what you have to do.
There's supposed to be one. Okay. So I have three.
A lot of work to do. Okay, so we need to go back. We're still on our calculators. We have to finish this last calculator problem. So everybody has a calculator today, hopefully, because soon we're going to have a quiz, and if you don't have a calculator, you'll have to rent one, and that gets expensive. It's dumb. Get your own calculator, have it with you so you know how to use it. Okay, we are on part 4B. Part 4B. Now, a lot of this is reviewed from yesterday, but there is one new piece. So here we go.
Here's an interruption. I need for Bryce Anchorage to gather his things and report to your front office, please.
Okay.
Thank you.
Bryce, we're going to learn a lot today, so watch the video, okay? Okay. All right, so now we're going to do 4B. So remember from yesterday, we typed 18, right?
Oh.
And then we go into our angle menu. Remember where that is? Second angle. Where's your calculator, Abby? Okay, then just make it there. That's it. You don't have one either? No, I do. Okay, you want to get yours out? I know, get it out, turn it on. We're pressing buttons. Okay, so we have pressed 18, and then we went into our angle menu, and the very first option is degrees, so we just hit enter. And now the calculator says 18 degrees. So then we type in 12. Now do you remember how to get that minute mark? We go back into the angle menu, and where is the minute mark? Right underneath the degree, right? So we go down, hit enter. Now, hit 13. Now this is where, and I don't understand it, but things are wild and wacky. The second symbol is not in the angle menu. The second symbol is above your plus sign. For me, it is green. It might be a different color for you, but whatever color it is, you have to use that button. So I'm going to press my alpha button, and then my plus sign, and that puts the second mark in there. Look above your plus sign, and you will see the second mark. See it? It looks like quotation marks. So whatever color it is, that's the button you have to press to get to that menu, to get to that option. Then you press enter, and your answer should be 18.2036.
Yup.
All right, let's try another one. There's another one on the sheet. All right? So I want everybody to finish the one you just did. I want everybody starting together here, so we're all pressing the same things. Okay, so we're ready now for 4C. Everybody's ready to begin. So we're going to press negative 152, because that's the problem. Then we need our degree mark, right? So remember where to find that? Second angle. And then it's the very first one, so just press enter. So now you have negative 152 degrees. Then we'll press 18, because that's the problem. And then second angle again, and go pick up the minute. It should click down 1 and press enter. And then 39. Okay, where did we say we were going to get that second symbol? Yeah, I got to use alpha plus. And you should have gotten for that one negative 152.3108. this next section, number 5, very, very important. There is one formula I want you to write down somewhere, maybe in the margin here or somewhere, put a box around it, put a star next to it. The formula is arc equals radius times radians. Anytime you see this picture, S is arc length. Anytime you see this picture, R is radius. Theta is central angle. This is a Greek symbol, Greek letter theta. Anytime you see that picture, I want that formula to pop into your head. So when I look at problem A, it says the radius is 10. The central angle is 2. And you're going to find the arc length. Kids, this is so simple. How do you find arc length?
Radius times radians.
Radius times radians. So the answer to the question is 20. Done. Move on. That's the answer. The length of the arc is 20. Now the next one is I got a little tricky. Same picture, so we're going to use the same formula, but this time I told you the arc length was 6 and the central angle is 1.5, and your job is to find the radius. We can use the same formula. We'll say arc length equals radius times radians.
Yeah.
So how will I find my
Divide.
radius? I'll divide. So 6 over 1.5, I think, is 4.
That's right.
Look at the next one. Again, a little bit tricky, but really not. Looks tricky. It says the arc length is 10. The radius is 4, and we want to find the angle. What does our formula say? Arc length equals radius, oops, which is 4, times radians. How will I find that? What will theta equal? 10 divided by 4, which reduces to 5 halves, or 2.5, if you'd rather write it that way. Everything seems incredibly simple. Until. Take a look at this next one. What is wrong with this scenario? It has a degree. And if you're going to use the formula, your angle has to be in radians. But you're not worried, because yesterday we talked about how to change from degrees to radians. How did we do that? Do you remember? You set up a proportion and cross multiply. So this is going to be a two-step problem. Before I can do the problem, I'm going to have to change this. So my Brownlow, remember how that works? We say pi is to 180. We always set that up. That never changes. And in this case, we would say what over here? What will this fraction be?
30 over 10?
No.
10 over 30?
X over 30.
I thought that. That was my next guess.
So 180x equals 30 pi, and x equals 30 pi over 180, which reduces to pi over 6. Now, that's not the answer. That's the biggest mistake kids make. They'll put that in the answer blank. that isn't the answer. That's this angle. To get the answer, we have to remember that arc equals radius times radians. So your answer is going to be 10 times pi over 6. Which would be 10 pi over 6 or 5 pi over 3. That's the answer to the question. To two-stepper. One more. Please don't freak out. It's a very scary looking problem. But you know, the first thing you have to do is deal with this. You need a radian measure, kids, not a degree, a radian. So, you know how to do that. Pi over 180 equals something over 90. I got pi over 2. Is that what you got?
Yeah.
Now, that is not the answer. That is just this angle. This is pi over 2. So now we'll do our formula. Our formula says that the arc length, which is 10 pi, that was a problem, equals the radius times the radian measure of the angle. I know it's got fractions, I know it's got pies, don't freak out. We need to figure out what r is, so I'm going to divide, or I'm going to multiply both sides by 2 over pi. Now, why would I do that? What happens if I multiply by 2 over pi?
They
What
cancel.
happens right here?
Cancellations,
They're gone.
constellations.
So r equals, this would be 20 pi over pi, which is just 20. So the radius is 20. Don't let yourself get freaked out just because of the arithmetic, okay? You can do it. Arc length equals radius times radians.
Wait, so the answer is 20? Okay. Okay.
Yep. Now, would you open your book to page 357? We're going to switch gears a little bit. One of the biggest uses of trigonometry is for navigation. So we have to be somewhat comfortable with compasses.
I don't know where this came from, but they ended up on
Okay? 357. Now you all know that this is east, this is north, this is west, and this is south, right? Everybody knows that?
Well, we're just gonna keep our hands to it.
If I drew a line right in the middle here, right in the middle of north and east, this would be called northeast. Would you agree with that?
Yes, I agree with that.
And this angle right here would be 45 degrees, and this one would be 45 degrees. Would you agree with that?
Yes.
Then, if I drew another angle right here, splitting the difference, cutting that in half, this angle would be 22 and a half, and this angle would be 22 and a half. And this would be called east-northeast. If I split this one, These would also be 22.5. And this would be called northeast. Now let's talk about, I think everybody gets that's northeast, right?
Is that a doorbell?
It's my phone.
Okay.
This is northeast, right? Everybody's got that?
Yes.
Now, why is this one called east-northeast and this one is called north-northeast?
Because it's more east than north.
If you split the difference on the east side, it's east-northeast. If you split the difference on the north side, it's north-northeast. So let's see if you really have it. Let me draw this one. What's this one?
South.
That one is just southeast. The one in the middle is just southeast. What would this one be? South-southeast. And this one would be east-southeast. You got it. And all of the angles, when you start splitting all this up, are going to be 22.5. Okay, so now the directions say, find east-southeast. It's right here. This is east-southeast. This is the first question. And find the angle measure that describes that direction. Now, this is the part you may not know. When we measure angles with a compass, it's different than when we do it normally. When we measure with a compass, we start at due north. Due north is 0. East is 90, south is 180, and west is 270.
Is this like real knowledge? Like,
This is real knowledge. This is fact. I am not kidding you or making this up. This is the real deal. So if an airline pilot is told to fly on a course of 90 degrees, 090, that's due east.
okay, that makes so many movies now more relatable.
Now, your job in problem number 6A is to tell me
I know where they're going.
this angle.
Yeah, I understand.
What is the angle for east-southeast? Well, this much of it would be 90, right?
Right.
And how much is this little one? I told you, they're all what? 22.5. So 112.5, that's exactly right.
That's under 20.
So if you were sailing a ship, flying an airplane, doing the space shuttle, whatever, and somebody said your course is 112.5, that would mean exactly east-southeast. All right? Let's try the next one. Southwest.
45.
Now, I don't have southwest drawn, but it would be here, right? That would be southwest.
Perfect line.
You got to start at 0. So we're coming around straight south. That would be 180, right?
Right.
And then how much more am I going if I'm going all the way to southwest?
180
wouldn't that
plus
be
45.
Another 45.
45.
So this would be 225.
It's my bench press.
West, northwest. Well, I don't have that drawn. So this one would be northwest.
What you give me?
Actually, I can't. Just the one.
Would west, northwest be this one or this one? It's the bottom one. This is west, northwest.
Wait, so every single section is 22.5 degrees. So 2 chunks is 45.
Yep.
Okay. Everything's making even more sense.
Now,
I can
I
follow.
want, this is the one I want, west, northwest. So I gotta start here. Well, if I go all the way to west, I've gone 270, right?
Right.
And then I gotta go one more section, so that would be
270 plus 2.
292.5, 270 plus 22.5.
Yes.
And then north,
This
northwest,
is pretty much a clock.
which would be this one. So now I'm looking for that one. So that's all the way around to west. And then I gotta add what? 3 22.5s? Or it might be easier. It's almost all the way around except for this part right here, right? So could I do 360 minus 22.5?
If you choose to.
I could and I do. And so what does that give me?
337. Because I know there's a 7.
337.5.
Oh, I meant like there's a 7 in
Now, look at problem 7. Because now you're going to apply that knowledge. Now you're going to do what we do with trigonometry.
it. During this time last year, they said they came during the lunch.
A ship leaves port and travels 15 miles on a course of 100 degrees. He then changes course and travels 2 miles. Draw a sketch of this journey. All right, so here's my compass point. Here's port. He travels on a course of 100 degrees. Now remember, if he went due north, that would be a course of
0.
0. If he went due east, that would be a course of
90 degrees.
90.
0, 90, 90.
He's going 100, so wouldn't that be just a little bit past 90?
Yeah, that's more like an east-southeast type flight going southbound.
So this is 100 degrees.
Telestations.
And he travels for 15 miles, it says. So I'm going to go ahead and mark it 15 miles. So that's a picture of 100 degrees, and then I made it 15 miles. Okay? Now, let's put another compass here, because he's starting over again. Now he's going to sail on a course of 200 degrees.
So that's more of a south-southwest type angle.
200 would be over here somewhere, right?
Right.
So he's traveling somewhere like this.
Yeah, that's about
This
200
would be
bingo.
200 degrees.
It's a hard bank left.
And he traveled 2 miles. So that one's going to be shorter than this one, right?
He should have just gone south at this point.
And now he's located right here. That's a picture of his journey. That's all you have to do is draw a picture of it. Now, when we get a little bit more knowledge under our belts, we're going to pretend this ship runs out of fuel, he's stranded. And then we're going to take an airplane and we're going to send it out here. We're going to come rescue these guys. So we're going to have to figure out how far and what course we'll need to fly on to get these guys.
Theoretically, would it only be 17 miles?
No.
Okay. Just
Okay. All right, so now we're on to part 4, or part 4.2, which is where tonight's homework is going to be. Some of last night's you probably couldn't do because we didn't finish it all, but now you probably ought to be able to go back and do last night's homework if you didn't do it. I ran into Bryce, this is probably why I got called out of class. He made the comment yesterday in the hallway, I happened to overhear him, we didn't have any homework.
Excuse me, do you know where you go to school?
Okay.
Do you know who you
So
got
now
for
I'm
green
looking at problem number 1A. And I've drawn a nice little picture for you. And I've asked you to find all 6 trig functions. Now this should not be a challenge for you because we have already talked about this, maybe not doing all 6 of them at once, but we've talked about how to do this. This is angle theta. All the problems involve that angle. So which side is this? Opposite. This is adjacent. And this one, of course, is the hypotenuse. So filling in all these blanks should be easy. Right? What's the sign? Let me write SOHCAHTOA up here.
Oh, that's opposite of hypotenuse.
So it's 2 over.
SOHCAHTOA, here we go. It's opposite over hypotenuse, right? So what's it going to be?
2.
2 over root 13.
Goes on.
And what do we know about radicals in the bottom?
You're crazy.
Yeah. So how do we fix that? Do you remember?
You
how
have to
fix
take
that?
the square root of both, cancel it out, multiply by the tangle 9 or 9 or east, south, east, backward.
We're going to multiply top and bottom by root 13. So we end up with 2 root 13s over 13. Remember doing that last year, folks?
Yeah, I remember that throwback.
What's the cosine?
Oh, that is the adjacent over hypotenuse. So if you just look on the right-hand side of the screen, you'll see it.
So that would be 3 over root 13.
That's about right.
Are you is that making sense to you?
Perfect sense, crystal
So we
clear.
have to rationalize that one too. So that will be 3 root 13 over 13. How about tangent?
2 over 3.
Tangent's going to be opposite over adjacent, 2 over 3. Now, here's the good news. These are just the reciprocals of those, right? So all we do is turn them over. Now let me give you a hint. When you turn over the sign, turn over this step. Because when you turn over that step, you'll get root 13 over 2. What would happen if you turned over this step? You'd have a radical in the bottom that you'd have to take care of. I don't want to do that. It's dumb, pointless. I can flip it here. So then I'm going to flip this one here. So this secant will be root 13 over 3. And the tangent will be, or excuse me, cotangent will be 3/2. Easy.
Oh, got you.
Now, I need to skip down to number 2 real quick. Why are we all standing up?
Because
Save like
you got lucky because I was about to back up this board and just DDT y'all through all these things.
Do your best with your homework. You might have some questions since we didn't get as far as we needed to. Julie, can you hand me my iPad?
Oh, yeah.
Miss Ford, is there a way I can make up that quiz? Because I missed that boat.
You missed that boat.
It's all right. I'll make up for it.